Today I'm gonna try to implement zoom and drag. With drag of elements, not of the canvas. I'm gonna put this music because last time I think I didn't get a copyright thing and they didn't cut the stream, so I'm gonna try it. So if they cut the stream, I think I'm probably gonna stop streaming and then come back maybe. And here I've been trying to implement drag already, but the physics is fucked up. And I think I'm not implementing the physics the correct way, but I'm not really sure like exactly what is wrong. There was a comment on the Discord. Someone said that you can implement just by using physics and then creating the force and then acceleration and then velocity. And I'm only using the force here. I'm not creating, modifying the acceleration and the velocity, so it might be the problem. But it also feels that it's not exactly correct, the force. So, but the equation should be correct. But I think that maybe I should remove the distance here, because I got this stuff from the VJS code. So the equation is simple, it's just k times x minus k times x. So the greater the distance is, the greater the force. But the problem is that in a realistic scenario, I think that it reaches an equilibrium because of the mass of the two different objects that are connected through the spring. But if there is no mass in the simulation, then if you just do minus k times x, they are gonna be connected to each other because there's no force to stop them at like an equilibrium. Because even if the k is very small, it's not gonna be zero at any point if you just k times x, unless the distance is zero. So like it's only gonna stop when they're connected. That's why it doesn't make a lot of sense to me. So there must be a way to make it so that they reach equilibrium without putting the mass, I think. But I'm not really sure. I think the way is just by dividing by distance. That's probably why they did it like this. But even then, it's not gonna be zero, obviously. So that doesn't make sense. So like, how can I make it so that it reaches an equilibrium at a certain x value? That's the question. And the reason why the events are not working is just because I think that I'm not changing the physics here. In the beginning was because of I tried and it wasn't working, and I think it was because of the collider. I wasn't updating the collider. The other thing that I'm not sure of is this physics step that I spent some time thinking about, because like what you have to do is just at each step of the mouse move, let's say, you have to update the rendering cycle. So I have to like call all these functions here, I think. Like on the example that I got from ChatGPT, it was just calling this renderer function, but it wasn't with a physics engine. And then the problem is that this function is being passed to the ticker from Pixi JS, and it's a callback function. And there's no way for me to access this function after I initialize here, because this is going to return the ticker, and then the ticker doesn't have direct access. So what happens when you pass this here, the callback function is going to create a ticker listener class, and it's going to pass the function to the ticker listener class. So there might be a way to connect to get to the ticker listener class, and I think that there is, because what this creates is a linked list that is confusing, and I don't understand really well how it works. But is this process here. So it's gonna be connected to the ticker class somehow through this ticker listener here. But the issue with that is that it's gonna depend on how many ticker listeners are connected to the app, I think. I think that might change the way that it is connected here and the way that you access, and that's gonna be a problem if I try to access. So I think it's not a very good solution to, because I need to have access to this function here. Like, let's say I wanna call this function exactly the way that it is here every time on the events here, so that I emulate the rendering effect, let's say. I think it's not the best solution. It is the biggest challenge that I'm having so far, is just thinking about like what is the best way to implement this, because I don't understand really well like what is supposed to be the pattern. And this is the stuff that I had from the beginning about the physics engine in particular, is that it seems that the way that you should do the physics engine is you should try to make as many things as possible, as many calculations as possible in the beginning of the simulation before rendering, and then everything else is going to be handled by this step of the physics engine. So you initialize everything with the forces, and at each step is going to calculate everything. But then the exception of that is the events, because on the events you need to change the physics. That's the problem. So because I'm changing the physics here, I have to update the physics engine, I think, like the values. And this is what I'm doing on these lines here, and then I have to update the force, I think. But then it feels weird, because then I don't know like what is the correct way to connect that with the loop from Pixi-JS, which it happens inside of the ticker. And then there's obviously the question of optimization of how many, because I want to minimize as much as possible all the calculations that I'm doing, like kind of like trying to cache everything as much as possible. That's because if it's not necessary to update, then it makes the visualization faster, I think. So I think here what I have to do is think about a way to calculate I think I need to pass the edges to this thing here, and then I have to loop through the edges. The problem is that the edges have to be a list of objects. I can't make the edges based on the nested objects. The other thing that I did was to translate I was using a list of objects for the nodes as well, but then I changed to a nested object. And I'm gonna have to change some algorithms on the graph and the way that I'm shaping the data to get into the visualization because of that. But I think it makes it better, because then if it's a nested object, I can put each node with a unique key by just making a value of a key of the object, of the nested object is going to be the node ID, and each one is going to be unique. And then if I want to make it so that so I provide the ability for people to create visualizations that don't have repeating nodes, let's say. All I have to do is just put a condition to see if the names of or labels of the nodes are the same, and then if they are, then I just create a new connection and create a new node. But having the unique ID for each node makes it so that I can just use that object to make the edges. I don't have to create another object to create the link between the ID and the bodies. I can just use the nested nodes object. But I think for the edges I need to keep it as a list of objects, because the edges are like dependent on the two different nodes, so it doesn't make sense, I think, to do nested objects. So I think I have to pass the edges here, and then I have to loop through the edges. There isn't a better way, because what I want to do is just, what is the most efficient way to figure out all the edges that are connected to the node that was selected here. So the way that it works is that on the mouse down, I loop over the nodes to calculate the distance, and I have the start X and Y of the position. So like here I'm using offset because the offset position is the relative position of the canvas in relationship to whatever is happening. I'm not 100% sure about this as well, because most examples tell you to use client X and client Y, which is the absolute position. So I think it might be more reliable to use client X and client Y and then calculate the relative position based on that. But I'm using offset for now because it's easier. So this is the position of the click event or the mouse down event on the canvas, or on the canvas, or whatever object you pass here, whatever DOM element you pass here. And then I'm looping over all the nodes, calculating the distance from that point to the node. And if the distance is smaller than the radius, it means that the event was inside of the node. So then I make this dragging variable to true and get the index of the node. And then based on that, I do the calculation here of the mouse move. So the current index represents the node, and I get the body and the collider. But I think here I have to loop over the edges again, because that's the only way to know what other nodes are connected to that node, because I have to update the forces, I think. If I didn't have to update the forces, then I think that's just this works. But I think the reason why it's not working right now is because I have to update the forces. So like it slowly gets unstable. This kind of works, and I think that's because of the forces. And I'm not 100% sure that I am calculating this stuff in the correct way as well, the forces in the correct way. I think this is the case because when I stop calculating the forces, I think it works. So I'm gonna spend some time thinking about this. Yeah, now like it's lagging a bit, but I think, yeah, so there's still a problem there, so I'm not sure. Maybe there's something else as well. Maybe I'm not updating everything that needs to be updated. Or this step of the physics engine is fucked up. Because the issue is also this delta here as well. It looks like it is fucking up there, so it might be something else that I'm missing that I don't understand really well. It could be the position here of the mouse as well. So here I'm only getting I'm updating the values should be at the mouse X and mouse Y, which is the position of the mouse, the current position of the mouse. But the collider when in the initialization is 0, so maybe if I change, or if I just comment this out, but then like the thing is it might fuck up as well because I have to update the value. So now I don't know, looks that it is more stable. Yeah, but now it's still there's something that is adding up, I think, errors because they're not updating correctly, and then that makes it so that the simulation fucks up. And now I can't grab here, like it's harder to grab, so I think that's I need to update the collider or something. It's probably the forces actually. Maybe the collider is fine, but then the forces, but I commented out the forces, so shouldn't be that, I think. Maybe it's the joints I have to... But the thing is, the joint should work from the beginning. So as long as I'm updating the positions of the body, the joint should be updated like by default, I think. And it's hard to think about what is the correct approach here. I think I might ask on the Discord for the Rapier. The problem is if I have to spend a bunch of time. I think I'm gonna have to spend a bunch of time anyway, eventually, on understanding the source code of the physics engine. And I'm trying to avoid that for now because there's so many other things that I need to think about, so. But it could be the delta, but I think that the delta shouldn't be the problem because it shouldn't change that much, like it shouldn't change the physics engine, having this delta here be off sync with the renderer. The only thing that it should change is the delay on the visualization, I think. Like, let's say that this is faster than this one, then you would have like a misrepresentation of where the graphics are and where at what state the physics engine is, but you shouldn't make it so that the graph explodes. And vice versa is also the same thing, I think. So I think it's something to do with the whatever I need to update there on the physics engine. So I think that it is in these functions as well. The question is, and here I'm getting this the ticker, and then I looked at the source code to see what is being updated through each iteration of the ticker frame, or not sure what's the correct way to say it, but the cycle of the animation, and it looks like it uses delta time. So I'm just getting that and passing here to pass to the step on the physics instead of the events here. So maybe it's this value here that is off. And this is the stuff that doesn't make sense. I think that the problem is on the collider. Because it's the same thing that happened when I was trying to create the revolute joint here and didn't understand how it works really well. I was putting the body X, the from X here, in the same place that I'm putting the front body here. So what that does is that it creates a restriction on the node itself and makes the nodes explode because it's trying to get away from itself, let's say. So I think that the same, like a similar thing is happening here, so it makes me think that the problem is the collider. It shouldn't have anything to do with the force, because now I'm commenting all the force, so yes, should be, maybe you should look here as well. This is the stuff that is kind of weird, because here is set to 0, the translation. So I assume that the collider position is the relationship between the node itself. I'm not really sure if it makes sense to update here, but like yeah, it should blow up the thing, I think, if it is the wrong position. Maybe I should just read the documentation to see. The problem is that just the documentation is not going to be enough, I think, for me to understand exactly how it works. I probably need to look at the source code, try to understand. I'm trying to avoid that because it's going to be like a very long journey, and ideally I would be able to look at that once I figure everything out, because the first thing that I want to do is just try to move away from Pixi. So I want to make the zoom and drag events happen using Pixi first, Pixi-viewport, then move to my own zoom and drag events without using Pixi-viewport. Just copy the functions and try to yeah, I'm just gonna copy the whatever functions happen and then try to put the functions separately, then Pixi. And then after I manage to make that happen, then try to create another project and try to reconstruct Pixi from scratch using my own style of coding to see if I can like remove all of the stuff that is not necessary for my use case. Because I think that the way that they design Pixi, everything is gonna have its trade-offs. So I don't think it's bad. I think they had to design it that way because it makes more sense if you're building a library that a bunch of people are gonna use it. but then it adds a bunch of stuff that I'm not gonna need for my use case. So I'm gonna try to reconstruct that from zero to see exactly what's the stuff that I need, and like start trying to optimize the visualization more for my needs. And then from that point, then I can begin to study the physics engine, the source code. I think that makes more sense. So I'm trying to avoid doing that now. But maybe I won't be able to. I think I'm gonna open the Discord and I'm gonna see if there are any posts about events or any resources. I think I watched most videos on YouTube already and I couldn't find anything that explains really well. Like the most of the graphics programming stuff and game programming are on C++ or C. And it's hard to think about because they also don't talk about... Some of them do, but it's hard to translate into the stuff that I'm doing with the libraries that I'm using, about how to manage, because they don't talk about events, that's the thing. Because they're using C and C++, they just talk about the calculations of how to move, but not how to synchronize the events with the physics. Oh, one thing that I can do is just console log as well. Okay, console log on the problem with that is that it's kind of annoying because each body is gonna have its own position, so I'm gonna have to keep track of all the bodies and then console log in relationship to the bodies. So, but I'm thinking like console log the positions in the beginning of the simulation, and then yeah, how would I see if the update is correct? I'm pretty sure that I tried as well to put different values there of like putting dex, but it's just gonna explode the thing, I think, because this is the difference. So this is where the mouse event started, the mouse down event, and then this is where the mouse is currently at. So dex, setting the translation to the difference, I think it doesn't make a lot of sense, but maybe I think it's not gonna work. Yeah, it just explodes. Because the delta is just gonna be like, if I put that as the value, it's just gonna be completely off screen. So let's say that the starting position is 400, the current position is 500, the delta is 100, so it doesn't make sense to put the mouse at that position. And that's why I think I put it like this, but maybe should have watched the video again. The thing is, like, he doesn't, because the example I was watching, he doesn't talk about, he's not using a physics engine, so, and I think he uses this delta x and y, so because the thing is, if I wouldn't even need to track start x and start y if I'm using mouse x and mouse y, obviously. And I think that the reason why he tracks that in the example that I watched is because he's not using a physics engine. My situation is different because then I already have the positions of the objects in the simulation here, so I don't need to track this. I can just initialize them here. Maybe I should try that as actually, because it might be something like that is, but I think that that's not the problem. It's probably something else. Interesting. So I'm pretty sure that I have to update this as well. I think the problem with not updating, but if this is 0, it wouldn't make sense, because then you wouldn't have to update. That's the thing that is kind of weird, because here it initializes to 0, and I think I got this from an example. So it initializes to 0, which means that it makes me think that it is a relative position from the from the body itself. So the collider is 0 in relationship to the body that is gonna be wrapping to this body here. But then if that's the case, then why do you need to update the collider? Because it should always be 0 in relationship to the body. But I think that's, and this is the issue, is that I'm updating the position, but then it's like the collider updates through this step, but here I'm setting the translation of the body to this point. So there's a disconnection between them, I think. Now let's try to make 0 here, see if it changes anything. I remember there's something on the documentation that talks about this as well. When you use set translation on the rigid body, maybe you should read the character controller as well. And when you set translation on a rigid body, you have to be careful, because then there's something that happens, like it's kind of like you're teleporting the body. I think that's the problem. Like instead of the physics engine having a continuum of what's happening, it's like you're teleporting the body at each frame. So it makes the other calculations of the other stuff that is happening on the scene to be off. And then I think that these errors compound over time. I think that's the problem. Yeah, you should try to use ChatGPT. I'm not sure how old Rapier is, because I know that there were some breaking changes, so I think that ChatGPT is gonna have the older version, because I'm not using plugins, so It's probably gonna give me some, but maybe it will be helpful. What you think? Let's think about. It's a good question. What is the correct way to update Rapier JS widget? It could be something related to the offset as well. Maybe should use client X and Y and then get the position of the canvas X and Y. So get the position. Like the position is gonna be the difference between them. And there's also some calculations on the Pixi-JS event. That's the reason, like, they create the class. I think that they create a bunch of classes and then they do calculations to determine the point in the road. So it might be a problem like that, where I have to use some of those classes or try to create similar functions to calculate the relative position of the mouse or the events. This is a problem with ChatGPT. I think this might be just because of the way that they like have to censor ChatGPT. So it just apologizes when you, instead of saying what it actually thinks, let's say. But it might be just a problem with, I think it's more likely that it's a problem with the censoring. But obviously they have to do that because it's like an extremely difficult problem from OpenAI's point of view, because you don't know what are all the possible ways that people can use the large language model and then how that's going to affect everything else. So it makes sense, I think, to try to regulate the speech, but then is the whole problem of freedom of speech and the complexity that exists on that. So obviously I can't rely really much on this answer, I think. maybe the problem is because I'm not... Yeah, but... I was gonna say that I'm not updating the other nodes of the simulation, but they should be updated through this step, I think. And obviously, they're not gonna be moving unless there is a contact, but obviously it is possible that there is contact if you move the node to collide with the other one, but then it should be handled by this step, I think. But I think that probably the issue is this stuff that I was talking about, where like setting the translations, like teleporting the body. So there's a small like difference in the values from the other objects to the one that you're moving, because you're teleporting the one that you're moving, and then on the physics world is taking into account the other position. But I don't see, it doesn't seem like this is correct, because then like here I'm updating a position before I do this step, so but maybe this step takes into consideration the other value, but that wouldn't make sense, I think. And maybe reading the documentation for the character controller will help. I'm not really sure if I can look at the source codes because it's on WASP, so it might be like binary and I don't understand really well how it works. I know that it's coded in Rust and then I think it is compiled through WASP, and then there's this API like from JavaScript or TypeScript that communicates with the WASP files, I think. But then the source code is like written in Rust for the stuff, and you can only see the API that is used to communicate with the source code, but not the source code itself, unless you look into the Rust version, I think. Not really sure how it works. And the thing I don't understand there is that it looks like this tab should update the collider, but then like why there is a difference here when I don't set the translation. I think I didn't test like this. I think there is a difference if I just... Maybe it's because I'm only updating the position and not the other values. It could be that. So when I hold the thing, that's when it becomes unstable, I think. But if I just move and let go, then I think that it works. And here is weird because it isn't supposed to have force. Because I commented out the force, so like here they are repelling each other, but they shouldn't be. So I think there's a problem with the revolute joint, I think. I think that this might be the issue. Let me see how... I think I'm gonna try to see if I can update the joint. Let's roads, create impulse joints. Also gonna look into the character controller thing because it's gonna be useful, I think. That's great impulse joint. Yeah, maybe I should just put the... So I think what I have to do is find the edges. The thing is, like, is there a way to... When I think about how I'm gonna get the edges, the problem is that I'm gonna have to think about the way that I'm doing the graph. Because I could get, and I think I am getting the neighbors for each node when I create the graph. And that will allow me to just loop over the neighbors. Like that would be easier. But then it might make the other parts inefficient of the thing of creating the graph. So Because I think that from the example there, that's I'm manually creating to test this stuff. I'm not putting any neighbors here. So I have to think about how I'm gonna do this. I'm gonna decide to do this part here. But obviously it's much better if I have access to only the neighbors of that specific node, because then I can only loop over the neighbors only, and then, but then how would I get the edges? That's the problem. Oh, the neighbors would be the connection, so I wouldn't need to loop over all the edges, just loop over the neighbors and then update the positions based on the neighbors. But then the problem with doing like that is that it's gonna require me to calculate the neighbors each time that I'm creating the graph. I'm not really sure if that's good or not. I have to see how I'm doing the calculation again. I think I'm gonna have to change this anyway, because I changed the data structure for the nodes. I'm gonna have to update the network. Because here I am creating this node map, and I add the nodes. Obviously here is going to be a dictionary instead of doing like this. So let me think. I think I'm gonna do that now. It's probably better to... I remember there's an algorithm that I got from VJS as well, or PyVis, for the adjacent lists, and that's pretty much the algorithm that gets the neighbors, I think. I'm mapping node ID to list of node IDs. It is connected to, yeah. So this gets the neighbors for each node, I think. It's kind of confusing. And that's the issue. I think I need to... Because the only way to do that is after you have created the graph. So they have to be separated to some degree, because you can't create the... Like the neighbors depend on the way that you create the graph. So the logic for the graph is going to change. For creating the graph is going to change each time, depending on how I put the information. So I can't make that part of the libraries. And then the issue is that I'm going to have to remember each time that I'm creating the graph that I'm going to have to put the neighbors. And it's kind of annoying. Ideally, I would make everything based on stuff that I can set up on the graph itself, I think. That way it makes it easier to think about. So the function 0 on the physics engine should be like, I should create everything from the data structures that the graph creates. And I think that the edges is not a problem. We should make the nodes to be a nested dictionary, because it doesn't depend on the way that I'm gonna build the graph outside. Because it doesn't matter how many nodes you have, like you can always access the same way on the other parts of the code. It's always gonna be a nested dictionary. And then the edges is the same thing, because each additional edge is just gonna change the index of the array, but then it doesn't matter because you have to loop over anyway. The problem is the neighbors. I think that it makes more sense to create a function on the physics engine to get the neighbors. But then, like, yeah, it doesn't make a lot of difference because I'm gonna have to loop over each. I'm gonna have to loop over it anyway, so I think that. The question is, does it make sense to make it a requirement to always have the neighbors on the graph? Because you're gonna use it anyway. That's the thing. I think that's the question that I have to think about. Because for every calculation that I'm gonna do is gonna depend on the neighbors, I think. And seeing the neighbors is more efficient. Getting the neighbors is more efficient than looping over the entire graph. So this is the problem, I think, because yeah, that's the difference. If it's more flexible to leave the calculation for the physics, but then the problem is that you're gonna have to redo the calculation each time to get the neighbors. So you're doing like more work, I think, more computing, because you're gonna do the loop over all the edges. Or I guess I can loop over the edges and then calculate the neighbors on the physics as well. But then what's the difference between doing that and doing on the network? So maybe on the edges, when I calculate the edges here, maybe I should create another data structure here and keep track of the neighbors for each node. If that's the best way. Because that way I maintain the flexibility of the creating the graph part, and I also have the option of calculating the neighbors here. Ideally, I get all the neighbors one time, and then for each event I just update the positions of the node and its neighbors, instead of having to loop over all the graph over and over again. No, let me think about it. And the question is, what would be the data structure? So here I'm looping over the edges, and then I access the node map, which is just the nodes now. It's the dictionary of the nodes. Then I pass the ID for each one. And then here I would return that, because now I'm not returning anything, so it should be a dictionary with the node IDs and then a list. So node ID and list. I think that's the way. So after I do the edge here, just pass there. I think that's the best way. But then I can use this thing to calculate there, and then I retain the flexibility of the creating the graph in the first place there. I think it's more reliable this way, because then, like, if you make a mistake of not creating the graph, of not creating the neighbors, when you create the graph, it's still gonna work, and you can't couple the graph functions with the creating the neighbors because it's dynamic. So I think there are some instances where you don't want to have the neighbors, but it doesn't make a difference if you create them here. So for example, if you're doing an animation, because it's not gonna be, you're already looping over the edges anyway, so it's just gonna be like a small decrease in, or decreasing memory, let's say, or increasing in memory. So what name should I give to this? I think I need to make it with flat. I have to make it in 2 lines because I'm gonna have to push. And now I think it's cracked. So if it doesn't have the ID, I create initialize equal to a list or an array, and then I push the other node to the list or array. And if it does, I just push the other node. And the same thing for the other. And then I return this. And on the other one, I get I'll be right back. And this made me think as well that this might be wrong as well. Because here I'm looping over the values of the nodes and then I'm getting the index, but it might not be the case that the values of the index of the array of values here is not going to be the same as the index of the nested object. So maybe instead of doing like this, I do node.id. This is the other thing I thought about as well, is that like I was thinking about whether or not I was gonna have an issue because of the ID, because the ID would be the index instead of being part of the node. But then I just thought about that it doesn't make a lot of difference to also put the node ID inside of the object. So the ID is both the index of the object, but also the also value inside of the object, the node object itself. So like that way is double, so it's not very good because like you will have the index and the value inside of the object, but I think it's not that big of a deal, and it makes it easier because then I can, if I need it, I can use it, I think. And the ID is always going to be unique, the name can be the same. Yeah, so if the current index is the ID, then I can use here to get the neighbors and then a loop. Let me think about it. The problem is then like the position, how I'm gonna update the values, and what values do I have to update. I guess I only have to update the joint. I'll try to update the joint and see if it works. The problem is, do I have access to the joint? And I'm only putting the index as well. I'm putting the ID. So neighbor ID. So now I'm thinking about, I'm gonna make this equal to a variable and then put the variable inside of the, but the problem is I don't have, well I have the nodes I think, on node map. I think I'm gonna change the name so don't get confused later, because I changed this now, so. So what I can do is just, what I think is better to, I was gonna make a variable to call from and to, but I think it's better to just change the value directly by accessing like this, I think. And I'm just gonna create a new value. And then I can access here. I have to see the method. Yeah, that's the problem. How I'm gonna know if it is the anchor 1 or 2. I also think that's probably not what's wrong, because it makes more sense that you would update it automatically. So just changing the position of the node itself should update the joint, I think. But that's gonna be a problem if because then I'm gonna have to cache this stuff as well. And it's gonna be annoying. Just have to create a bunch of different values and think about how, like, which one to use there. Because there's no way for me to know, like, what order they are connected by from the edge. And I might have to change everything, I think. I change the way that I'm making the edges, so I keep track of which one, what is the order of them. I think I would have to keep track of on the nodes, and then it becomes like a mess, I think, because then, like, before I create this, I will have to figure out how to put the value of the neighbors on the nodes for each node, and then also specify if it is from or true. Or I can make another way would be to just, like, select which one I'm gonna put the values from. So, like, I only add to the neighbors if it is to the node, and then if it is from, I don't. But then that's also, like, it becomes a lot more confusing, I think. It feels like it's not the correct way. It's just so overcomplicated. So maybe I shouldn't. The problem is that there isn't anything on the documentation, I think, that talks about this. I think I'm just gonna. It's almost gonna remove the camera, go eat or eat something, and then just read this documentation again. But I think they are not gonna talk about this kind of stuff here, and whether or not it is gonna be updated. I think that it should be updated automatically, but then like I don't have any other idea of why. There must be something that it doesn't update automatically, or by changing the position manually fucks up the simulation for the rest of the things, because otherwise there wouldn't be a problem. I think like the nodes should never explode, I think, just by the movement, because it doesn't matter how you move the node with the mouse, the force is never going to be like increase that drastically from the collision that is going to make the nodes explode, I think. So I think that there is something that is slightly off, that isn't being updated correctly, and then because of that it fucks up. Also, let me think. Because I'm looping over the neighbors, so the current node should be the current index. Which means I should only update one anchor inside here and should update the other one outside, and then make the based on the current index current, but then it should be, yeah, maybe it has to be inside, because it should be in relationship to the other node, and then I'm gonna have to access the body. It's quite annoying. Or maybe it's better to just and it also doesn't make a lot of sense actually, as it should be, so maybe this should be neighbor anyway. I think that it doesn't matter because they are going to be the same joint, so, but I think it's better to put the same one here. Only the anchor should change. And the problem is obviously I don't know which one is which, that's the issue. So like in one of the nodes it might be this order, but the other one might be the other way. So because the anchor one would be the other node, and that would make it explode, I think. That's the issue. So if I want to solve this, I'm gonna have to change everything else, I think. It's not very good. I think there must be some other solution, or maybe this is not necessary. It feels like it is not the best approach. I think that it makes more sense in my mind that it would automatically update the joint once you change the position of one of the nodes. That would make more sense, but obviously I don't understand how they designed the physics engine, or there might be like different way to think about it. And this seems like, yeah, but now explodes, so, which is what I was thinking about. See if I change the order, if it's gonna change anything. I think it's not gonna change, but at least it works. At least the neighbors thing is working, I think. Yeah, now it doesn't. Oh, interesting. I guess the value is wrong, probably. One of them. Or obviously there's something that I'm fucking up here. And this is obviously wrong. Has to be the collider, I think. Maybe if I change the... Maybe the problem is the X and Y that I'm using. Or it can be the stop here as well. But the stop doesn't make a lot of sense. It must be the problem with the collider, I think. It's something related to the collider. Because if it was the body, then you wouldn't... Like, you wouldn't move to the right position. It's only a problem when they collide. So, there's something that goes on when they collide that fucks up everything else. It's also weird that there is this, like, resistance, or... It might be because it's either the collider or the joint, or both of them. There shouldn't be a problem approaching them, I think. Because now I don't have any force there, so... I think I'm gonna eat something and then read the documentation. It's probably the best thing to do. Oh, this part as well might give me useful information. It's essentially the same pattern, I think, but in a different way. Because I'm trying to implement a kind of like a controller to move the nose around. It's gonna get pretty annoying on the zoom as well. I think that's just the beginning. I'm not very excited about this because obviously I still suck at it. So I think this is the most challenging part. Because once I understand how the physics engine is working and how it's related to the view, how to synchronize both of them, I think that after that it's gonna become a lot easier. But this part is the hardest one because there's a bunch of stuff that I don't know about the source code of the engine, and also how the positions, the zoom, especially zoom and dragging the canvas is gonna be very annoying, I think, because I'm gonna have to think about how are all the positions being changed through the visualization, and then how the physics engine is gonna be, what state's gonna be in relationship to that, and how to update the physics engine. I think that there isn't gonna be a simple way. You just have to update everything that happens on the visualization every time that you change the zoom or drag the canvas. Because obviously the position of everything is gonna be changed, so... But it makes it a lot easier if the physics engine updates itself after changing the values of the X and Y from the objects. And the colliders. But if it doesn't, then it's gonna be a pain in the ass, I think. The other thing that I thought about is that maybe I was thinking about separating this stuff into another function, and then just calling everything, initializing everything again each time there is an event, but then it doesn't seem that is very good as well. That way there might be like a lot of stuff that I calculate again that's not necessary. That's the challenge. But I think it would be easier. But I think that way, if I do it that way, it doesn't solve the problem because it's still the same issue. Because the only reason why I can do things the way that I'm doing here is because I'm spawning each one on a random place in the beginning. So, like if I call everything again, it doesn't change the problem because I still have to update the positions of everything. And it's like from the place that they were to the new place, and figure out how that changing the position on Pixi, how it can change in the same way on the engine. I think there's not gonna be... I think I'm gonna have to look at the source code, spend a bunch of time studying the source code. I'm gonna ask a question on Discord as well, just thinking about what is the best way to ask. But I think it's gonna be unlikely that someone gives a response, because I don't think that people are very active there on the Discord. Obviously it's a bonus if you get a response. It's not like anybody owes you anything, so. But I think I'm gonna have to... Maybe the blog has useful stuff as well. It's weird to me that I couldn't find any video talking about this, because it seems like it should be a very common problem in graphics programming. Because anything that you're gonna do is you're probably gonna have events. And then if you're using a physics engine and a visualization library, there should be, like, it should be a common issue to try to synchronize the two. So there must be, maybe I'm looking in the wrong way as well, searching in the wrong way. There's only stuff about creating a physics engine. I think I already watched most of these videos, and I think they don't, if I remember correctly, they don't talk about this stuff. So let me think about it. I think the only thing that you have to update is the positions. But that's the thing. I have to understand how... The key is to understand how the solver, physics solver, is updating the state of the world. Because the link between the two is obviously going to be the positions of everything. The visualization has the positions, and then that's how you decide how you're going to draw the stuff. And the physics has the forces, which is just going to be like invisible tensors that are going to dictate the movement of everything. so the connection between synchronizing them is through the positions. But then as a consequence of changing the positions, I have to understand how the physics engine is gonna change the calculations. What stuff I need to manually update, and concern that I have is that there isn't a way to update, or I have to update the Revolut joint. But then it might be the case that I can, instead of doing the way that I'm doing now, which creating the joint, I can just I just thought about this now. I can just comment this out and see if it's gonna fuck up the thing there. I was gonna say that I can just do it with the forces instead of using the joint then. And because the forces are gonna be easier, I think, to recalculate. Because it only depends on the position, so the joint depends on the order of them. So something. Interesting. And that's the problem, is because but there should be the collider should work. But it's not working now. Let's see. I do this. Oh, now it works. Interesting. So I think I shouldn't update. So it's probably the joint that is the problem. So I think what I should probably do is just use the force instead of using the joint, because it's gonna be a lot easier. And I think the problem is the joint. So I shouldn't update the collider because it's the stuff that I was thinking about, and it makes more sense that if I initialize the collider as 0, the position, then the position should be in relationship to the object itself and not the absolute position. So if I update, it should be in the mouse position, the collision is going to be outside of the body that is being drawn. So I think that you don't need to update the collider. But then the issue there in the simulation is that I'm manually changing the position, but the joint doesn't change as a result of manually changing the position on the physics simulation. So because the joint is slightly off at each iteration, then it compounds the effect and the nose explodes at some point. So I think I'm gonna have to do it with force, but I'm gonna remove the camera, eat something while I read the documentation. And then I'm gonna see if I can fix, or if I can just do it with the force. Also, I think I'm gonna watch this video again. Because the thing is that the mathematics is simple for applying, but I'm not really sure if I'm... Because the thing that is fucking me up is it doesn't make sense, like, just with the force, the way that I'm doing there, it doesn't make sense for them to reach an equilibrium, because it's just minus k times x. So it should never reach 0. Like, the only reason why it reaches 0 in other cases is because you have other forces. So I either have to set some density or mass or something like that, or put gravity on the simulation. And then it's gonna be annoying, because then is like the relationship between vectors, which you can move around, and then you have to think about like what is the best way to emulate until it. Because ideally what I want to achieve is determine what point they're gonna reach an equilibrium by the size of k. Because by doing that, it's gonna allow me to put the customization, allow for people to customize how big the spread is between the nodes, the size of the spring. It's gonna be correlated with the force. So the magnitude of k. So it should be, they should reach an equilibrium in proportion to the magnitude of k. So the bigger the k, the smaller the x. I think the force should be on the two different nodes. I think that's the thing. But then the thing is that one of the forces has to be slightly bigger than the other. Just some proportion that is going to determine the balance of them, obviously. So like they are both in proportion to x, but then they are inversely correlated, I think. Because that way you would create the effect, I think. So one of them should, yeah, but then, or both of them should decrease with k. With, yeah, the bigger the x, they should, the smaller the x, they should decrease. And then they should be opposite to reach a balance at some x. Yeah, so it's probably k1 times x1 is equal to k2 times x2. It's simple, but it's kind of annoying to think about. Yeah, but I'm gonna remove the camera and I'm gonna watch this video and then read the documentation while I eat some stuff, so be right back.
Hello and welcome to a coding challenge about springs. This is the example that I make in this coding challenge. This is the end product. I'm just going to jump right in, but let me say this one's a little bit long. I mean, some of my videos are a lot longer than this one, but I'm going to go through this very slowly. So I'm going to start with this idea of calculating a spring force with just a single variable, like the y value moving up and down. Then I'm going to look at vectors. What does it mean to have a spring force be calculated with a vector? And that's going to allow me to transition into making things like this, where I have a system of particle objects and spring objects, and everything is connected, and everything's all boogie all day long. So without further ado, enjoy. I'm going to begin this journey through exploring springs with Hooke's law. So Hooke's law is named for Robert Hooke, a British physicist, yes, who developed the formula, this law in the 1660s. So Hooke's law was originally stated in Latin as ut tensio sic vis, or as the extension, so the force. But it's more commonly written out as an equation, and the equation looks like this. As the extension, x standing in for the extension, another word for that might be displacement, so goes the force. K is a value commonly referred to as the spring constant. So it's how stiff is the spring, how springy is the spring, if you will. To understand what the extension is or displacement is, let's draw the diagram as follows. A spring is made up of three things: an anchor, a bob, hi Bob, and the spring, the pointy thing, the spring itself. This thing is really the spring. So if the spring is at rest, meaning it's not moving at all, then we have something called the rest length, which is the distance between one end and the other end of the spring, or in this case the anchor and the bob. This is the rest length. If we were intuitively, you probably understand the spring as if I were to pull it down and release, it would spring back up. If I were to contract it and push it in, it would spring back out. That contraction or that extension is the displacement or the extension. So let's say I were to pull it down to here, the distance between where this bob currently is and where it would be at rest, this is known as the extension, or in this case, x. And the reason why the -1 is there is because even though the extension is positive, the force is pulling back in a negative direction, the opposite direction of that extension itself. Ultimately, I want to do this with vectors, these little things known as arrows, so that this could be anywhere, and the spring could point to any which way, but let's work it out just in a sort of one-dimensional spring, which is a single y value first. I'll begin with just this really basic sketch, just one variable, just y itself. The y being 200. So we'll say that y position 200, the spring will assume is attached to the top, and then the rest length would therefore be 200, or 200 minus y. So the displacement, or x, would be wherever the current y is, minus 200. And I should make that a variable. So in this case, the displacement is 0. The spring shouldn't move, which is what I see. But what happens if the displacement is not 0? Like if I make it 250. So clearly it should spring back up. So I need to calculate that force that I've got over there. And I can make up a spring constant. Let's just use the value 1 for lack of anything else right now. So what do I do with that force? How does that force change the y position? Well, this goes back to the sort of core foundational principles of my nature of code series. An object has a position, the velocity changes the position, the acceleration changes the velocity. I covered that extensively. I'll link to those videos here. Other thing that's really critical about that series is Newton's second law. Force equals mass times acceleration. And if I were to simplify that law and just say, well, forget about the mass, it's equal to 1 for everything in our world, force equals acceleration, or acceleration equals force. So if I were to say the velocity changes by the force, which is the same as acceleration, and the position, which is y in this case, changes by the velocity, that's all I need. Change y by velocity, change velocity by force. The only thing is I need a velocity variable, and I need it to start at 0. Oh boy, okay, interesting. I'm getting something. It's springy for sure, but I think the issue here is my value of k is much too high. So let's use a lower value. And we can see there it is, springing back and forth. Look at that spring. Oh, it's so springy. So let me add a little damping in here and just say velocity times equals 0.99, meaning it's going to lose 1% of its velocity every time, every frame. And that's kind of like how you might imagine maybe there's some air resistance or some other kind of force that slows the spring down over time. And eventually it comes back to at rest. All right, so you can pause this video now and maybe try some interesting things. Have more than one spring. Could you kind of move it up and down with the mouse? Could you have it go left and right? But really, there's not a lot that I can do with this without adding in the idea of a vector. So let me redraw this diagram with it at an angle so that we can bring in the concept of vectors here. I mean, the concept of vectors could have existed with my previous diagram. It's just I think I'm going to be able to illustrate it better if it's at an angle. Now, if vectors are unfamiliar to you, again, I could refer you back to that whole video series about vectors, but the idea of a vector in one sentence is an entity with magnitude and direction. And so I could draw it in this diagram here as an arrow. This could be the spring force. It has two elements to it. It has its direction, which way is it pointing, back towards the bob, or towards the anchor, I suppose, and it has a magnitude. How strong is it? What is its length? This formula still gives me the magnitude. The force of the spring, the magnitude, the length of this vector is negative k, the spring constant, times x, the displacement. The issue is I need to figure out the direction. And the way that I can figure out the direction is if I know the anchor point, if I know this as position A, and I know where the bob is, currently down here, if I call this position B, I can create a vector that points from A all the way to B by taking B minus A. If we think of a vector as having two components, an x component and a y component, I just need to subtract b's x minus a's x to get this value, b's y minus a's y, it was very awkward to say, to get this value, b minus a. Whew. So coming back to the code, and let me create a new version of this. Instead of y, I want to have position, or maybe I'll call it bob. And let's also have a vector that keeps track of the position of the anchor. So you can see the create vector function creates the vector, and it's really just storing in x and y. 300 for x, 200 for y, 300 for x, 0 for y. Let's draw both of them. I'm going to comment this stuff out. And we can see I have two vectors, one for the bob position, one for the anchor position. Now, I need to get a vector that points from the anchor to the bob. Now, this might look like a totally insane line of code to you. It would be much nicer if I could just write bob minus anchor. I have to use the specific vector functions. This one is for subtract. I can make a vector from subtracting bob minus anchor. Again, all this stuff is covered quite more extensively in my vector videos. But for now, we just realize that in that side, that variable v is a vector that points from here all the way to there. A vector that is exclusively noting the direction is what's known as a unit vector of length 1. So I can call this function normalize to take that vector and normalize it to a unit length 1. In a way, I can sort of add it to this formula here. V with a hat on it. This means the unit vector, this is the direction. So I have a unit vector pointing in this direction. I just need to multiply it by the spring constant, the displacement, and then reverse its direction to -1 to go this way. V dot multiply times k, v dot multiply -1, and then v dot multiply by the displacement. How do I get the displacement? Aha, guess what? Remember when I got this vector that pointed all the way from A to B? The magnitude of that vector, the length of that vector is the distance between those 2 points. Perfect. So before I normalize it, let's say let x equals v dot mag. And obviously I'm being silly by having these 3 lines of code. I can multiply it by -1 times k times x. That is now the spring force. And I think I'd rather rename this variable now to force. And I've done essentially exactly what's in these 2 lines of code, but now with a vector. Now I just need to adjust these 2 lines of code to work with vectors. I need to have velocity has to be a vector. Oh, so this has to be a vector. And force is already a vector, so I can change this to adding the force to velocity. That's the vector way of adding. And then bob dot add velocity, and then velocity multiplied by 0.99. So again, I'm doing everything exactly as before. I just needed instead to, oh, interesting. Oh, look at this. I made a mistake. Okay, hold on, but let me finish my thought. I basically just changed everything, but one of the things about working with P5 vector is you can't use plus, minus, multiply, the traditional operators. I've got to use the mathematical function. Velocity.add, velocity.multiply, et cetera, et cetera. So, but I forgot something. I forgot about the rest length. Right? We still have this rest length of 200. X is not just the raw magnitude of this particular vector. It's this particular vector minus the rest length. It's this displacement. So I should say x equals force.mag minus rest length. And, oh, well, I should move the bob down 50 pixels. And we can see it's springing. I should probably draw a line just to like have that line in there. And silly, but I think I prefer having the line before the circle. And there we go. We've got our nice spring. Let's see what happens if I take the spring and move it off to the side. If I've done everything right with vectors, I should be able to position that spring anywhere, and it will move in the same fashion. Okay, so let's give it a start of 350, 250. And there you go. Now you might be sort of wondering, like, that's weird. It feels like it should be sort of falling down or coming around to the center. Well, maybe if there were gravity, but this is just a totally made up thing. So this is just, it's almost more like a top-down view where I'm looking at a table before you're pulling something out and springing back and forth. But it is interesting to think about, what if I do add gravity here? And yes, this is an oversimplification because I'm not thinking about mass and all sorts of other factors, but I could just make gravity a vector that points down, and then I could also add that force to the velocity. And now you see, it's kind of, interestingly enough, acting like a pendulum. Let's move it all the way over to the side and see what happens. And it's kind of awkward and weird, but we've got a springy pendulum swinging back and forth. Maybe that gravity should be a lot stronger. Maybe I should be thinking about math. I'll leave you to play with all of that. Just to add one more thing to this, I think it would make sense for me to be able to move the bob around with the mouse, and I could do this in a much more elegant way. But I'm just going to say if mouse is pressed, I'm going to set the bob's position to the mouse location, and then also I'm going to set the velocity to 0 because I'm locking it in place. It's no longer moving. So I can click the mouse and I can move it anywhere I want. So if I move it over here, it should spring back up. And then if I click the mouse again, I can move it here, and it'll spring back down. So that's just one thing for you to see. You can sort of play with it. Again, awkward interaction. I encourage you to see what kinds of things you can add to this to make it feel a little bit more elegant and visualize it in a different way. But I'm not done yet. I have barely scratched the surface of what's possible to do with springs. And in order to get further with this, I need to expand my thinking beyond the idea of just there's one anchor, there's one bob, there's one spring. I should really not even be distinguishing between the idea of an anchor and a bob. Really what I want to have are particles and springs. Let's say I have a bunch of particles like this, and each one is connected with a spring. I pull one, it pulls the other, which pulls the other, which pulls the other. I can start to create simulations of soft bodies. I can even make a square, attach the edges with springs, put some cross-hatching in it with springs, and I've kind of almost got a skeleton of a squishy, spongy body. Now, ultimately, I have video tutorials that show a lot more about how to do this with physics libraries like toxic libs. And you can go explore those. You don't need to code your own spring forces, but I'm just going to go with it. What I want to do is create a particle class, which would represent any one of these dots, and then a spring class, which would represent any one of these lines, and have the spring class be responsible for the spring force calculation and see what happens. Now, as much as I might like just to sit here and type out all the code for a particle class, I've done this in so many videos before, and it's outlined in chapter 4 of the nature of code. So I'm going to go over to that example that I have on GitHub, which has an entire particle class, and I'm going to bring that into my code. I'll talk through what the bits and pieces are in there, but rather than type it all the way through. I'm going to make a new file called particle.js, reference it in index.html, and then paste in that code. Now, there's a few things that I don't need. For example, I don't need this idea of lifespan because I'm not going to have particles that fade away in this example, though you could conceivably have that. I'm going to get rid of this run function because I want to just use update and display separately. I like to call this show these days. I'll change it to show. No real reason. And also don't need this isDead function because, again, the particles are going to live forever. It's a wonderful place where particles live forever. So what is this particle? It's an object that has a position, a velocity, and acceleration. It happens to have a mass, although the mass is just one. It has an apply force function, which takes any given force, applies it to the acceleration, and it has an update method, which once again, I can get rid of this lifespan, add the acceleration to the velocity, add the velocity to the position, and then it has a show function, which draws it. Going to the sketch, I want Bob and Anchor to be particles now. So I want to say Bob is a new particle, Anchor is a new particle. And I'm passing them the xy position of where they begin. So just checking the particle system class. I did this in a slightly different way. So let's give the constructor arguments xy and say create vector xy. I guess this particle also is initialized with a random velocity, but I don't want that. So create vector 0, 0, 0. Now I should be able to get rid of velocity from here because velocity is part of the particle itself. Gravity you can still consider part of the world, so that could be a global variable out in the main sketch area, but I'll worry about that later. Ultimately, let me get rid of circle, these two calls to circle, and all the fill and the stroke, and I just want to say Bob.show, Anchor.show. Get rid of this, and I'll comment all this out. Great, so there are the Bob and the Anchor. Let's move the Bob down a little bit, and also, and this is all a little bit silly, but I'm going to make them a little bit bigger. I can get the nice blue color I had before, and there we go. So what's next? I want to take the idea of a spring, right, which is here, the rest length k, it's the idea of being connected between the Bob and the Anchor. I want to package that all up into a spring object. For example, I ultimately, like velocity shouldn't be here. I just need one more variable. I need to call it spring, and these would not be separate variables anymore. I would then just say spring equals a new spring. Maybe it has a value of k of 0.1. It has a rest length of 200, and it connects the Bob and the Anchor. Right? These are all the pieces of data that I need for a spring. What is it connected between? What is k, and what is the rest length? Clearly, I need another JavaScript file to put my spring class. Let me fill out the basic skeletal structure of the class. What are the elements that I need? A value of k, a rest length, and two particles. These can all be arguments of the constructor. Then, when it's time to update the spring, what do? Hooke's law. This is where that should go. The idea of updating the spring is calculating the spring force and applying it to those two particles. So all of this code that I worked out before can go right in there. Now, I changed the name of some things. So the force, I'm subtracting a from b now inside this generic spring class. The rest length is a property, so I need this dot. And k is a property, so I need this dot. And then I need to apply those forces. However, there's a little bit of an issue here, right? If the force is being applied to both particles, the force, if this is the spring, and I were to extend it, the force for this particle would point inward, and the force for this particle would also point inward, pointing in opposite directions. So let's take out the -1 here, apply it to this particle, then multiply by -1 to reverse its direction, and apply it to the next particle. I might have gotten which one should be -1. If I can think about it and probably get it right, we're just going to keep going. I also want to draw the spring. I'm going to say stroke, wait for. So this became a little bit convoluted. I almost just typed this .a.x, this .b.x, but I forgot the actual x value is inside of a position vector inside of the particle A. So I've got to draw a line between A's position x, A's position y, B's position x, B's position y. So let's go back to sketch and try adding in a spring.show. Now we see that line, and this is very silly, but I only have these after that. Okay, so now we see them connected, and I don't know, I should play a drum roll or something. If I just type spring.update, is that force going to be applied and it's going to work? I'm going to type it very slowly with my eyes closed. There's no chance this works. No, okay, I got an error. Good. Well, it wouldn't be a coding challenge if I didn't get any errors. There's an error as copy could not be called. v.1.copy is not a function. Spring line 11. All right, let's go back to spring line 11. Oh, look at that. So the mistake that I didn't make inside of line, I made up in update. I want to subtract B's position minus A's position, but not the particles themselves. I need to say A.position and B.position. Okay, good. I don't know. I don't have any errors, but I don't see anything moving. Oh, guess what? So I'm applying the spring force to the particles, but the particles I'm not calling the update method. The update method is once that spring force ends up in the acceleration, it updates their velocity and updates their position. So that is something I also need to add. Bob.update, Anchor.update, Spring.update. Whoa. Okay, I think maybe I had the directions wrong. So most likely it's the other way around. If I go back into the spring, this makes sense. I want to take the one without the -1 and apply it to B, and one with -1 and apply it to A. No? Oh yeah, whoa. This is kind of interesting. Something is wrong here. Oh, look at this. There's just like a literal typo. I said this .position. I don't know what it's getting there. There we go. That's what it should have been all along. And actually, I had it right in my head, but I should have said B minus A, and then this would be then this would be A, and this would be B. There we go. Now, there's no other forces in the system. There's no friction or drag force in the system. So I might here in the particles function, if I wanted to optionally, I could include that back. And over time, you can see it would eventually spring to kind of being at rest. Let's add back in the mouse control. So now you can see as I drag this around, I'm kind of pulling this thing that's kind of attached to me by a spring, and I can kind of swing it around and do all sorts of fun physicsy things with it. But I'm still missing those sort of wonderful possibilities of creating an entirely interconnected system. So I know there's just so many different directions this can go in, and I really want you to try and experiment on your own, but I'll just give you a little bit of a starting point. Let's create a line of springs. So first, let me give myself a lot more vertical space to play with. And instead of a separate Bob and an Anchor and a single spring, let me make two arrays. Then let's sort of let's space out particles by an arbitrary number. I'll just say 50 pixels. And I'm going to create 5 particles. And instead of showing and updating each individual one, let me do that in a loop. Great, there's all my particles. Let's space them out a little bit more. I also want to make them kind of smaller. And there we go. Now I need to connect each one with a spring. How do I do that? Looking at this, I can see that the second particle should be connected to the first. I mean, index 0, index 1, so index 1 should be connected to index 0, index 2 to index 1. So as long as I'm not in this loop in the 0 element, as long as I'm not in the first particle, then A is particles index I, and B is particles index I minus 1, the previous one. And so the spring that I want to have is a new spring. Maybe the rest length is spacing. What was the order of the things in the constructor? K, rest length A, B. I'm going to make a global variable K. Obviously, could all have individual Ks, but I'm not going to worry about that. K, spacing, particle A, particle B. Then let me add that to the array of springs. So this is a way of saying every particle connect to the previous one in the array. Then I want to update and show all the springs. So far, so good. But how do I know if this is really working, right? Everything's at rest, so nothing's moving. Well, what if I were to say, I'll consider like the tail, meaning the last one. I'm going to say let tail equals particles, index the length minus 1, which is the last one. And if the mouse is pressed, set the tail's position and the tail's velocity. There we go. Look at them all squishy squashy with each other. That is awesome. And I can do things like make the spacing 20 and have 20 of them. And I can start to pull them like this. I could also consider having an option in the particle class itself to have a Boolean variable called lock. Basically, if this particle, I'll call it locked. If this particle is locked, or if it's not locked, update all the physics. So basically, if a particle is locked, no physics. It can't move, it can't do anything. Then I could say in the main sketch, after I make all the particles index 0, locked equals true. So that first particle will always be locked to the top. Now, I've made, oh, is the rest length still like 200? No. I wonder if I want to make, I'm just curious, like this is very squishy. Like what if, I guess maybe if I increase the actual k value. Yeah, this is sort of more what I might have imagined. But also now I could add back in some gravity to make it feel like it's a thing that's hanging. So let's actually add back in the gravity. Basically, I'm also going to say p apply force gravity. So take that gravity force that I created, and you can see, oh, it's pulling them down. So that makes sense, right? It would always pull it down slightly. I almost don't want to see the particles, so I'm going to take out the showing the particles. So I just have this string, and I can kind of like move it around. Let's give myself a lot more space to work with. Set it in the middle, and go back to 50, and just have like 5. And we can see all the kinds of different behaviors I get. So there's lots of parameters of the system that could be played with. A place where you might start is just change the way this is being drawn. Am I drawing the particles? Am I drawing the springs? Which things? How am I drawing them? How am I connecting them? For example, what if I use begin shape and end shape instead of with the positions of all the particles to connect them with vertices? Let's see. Look at this. It's actually a closed shape, so it's almost as if I have this piece of cloth that I'm kind of like swinging around. And incidentally, I could use curve vertex. And now it's going to look much more sort of curvy along the side. Now, strangely enough, it looks like where's the top point and the bottom point? One of the things about curves, and this is a bit of an aside here, but curves need an entry point into the curve defined and an exit point out of the curve defined. One quick thing that I could do is just, I already have this tail. What I'm just going to do, I could just say, let's add an additional vertex for the tail, and then also for the head. So I'm just doubling up on the first and last point. And now we can see, and I kind of want to, I love this idea of this cloth, but ultimately, let's just see what happens if I say no fill. You can see this feels much more like this sort of soft string that I am curling around. All right, so I really hope that you kind of enjoyed this long process of starting with just like a single variable, moving to vectors, and then moving to objects. If you create something from this, please look in the video description. There's a link to the Coding Train website where there is a web page that you can share a link to your own creation. I think there's a lot of possibilities here, whether you explore the way this is visualized, whether you explore how you are mapping out your whole structure. Can you make like a little squishy robot character out of a head and a body and some legs? There's a lot of things you could do here. Of course, I should also note that this is a common enough technique that there are many other physics libraries that you could use that have particles and springs built into them, Box2D, Matter.js, Toxic Libs, and I do have other videos that cover those. There's something, and a lot of them have more robust and accurate techniques in terms of how the actual physics is calculated. So I encourage you to explore those. I'll leave links in the video description for you to explore those. But there's something nice about having it right here in your code. This will integrate into any P5 sketch that you already have. If you've been working through the nature of coding and have sketches with different forces in them, spring forces will just add right in seamlessly because this is set up in the way that all those examples are set up. So there's a lot of possibilities here. Thank you so much for staying all the way to the end of this video, and I'll see you next time on the Coding Train. Bye!
Physics Simulation with Rapier, 2021 Roadmap. Sebastian Crozet. Happy New Year, everyone. The year 2020 is over, so it is time to see what we did so far on our Rapier physics engine. And what are our plans for 2021? Rapier in 2020 hash. Rapier is a free and open source physics engine for games, animation, and robotics, written entirely with the Rust programming language. It focuses on performance, portability, and, optional, cross-platform determinism. We currently provide 4 Rust crates for Rapier and 2 NPM packages. Rapier 2D is optimized for 2D physics. Rapier 3D is optimized for 3D physics. Bevy_Rapier 2D for using Rapier 2D with the Bevy game engine. Bevy_Rapier 3D for using Rapier 3D with the Bevy game engine. At dim/Rapier 2D for using the WASM version of Rapier 2D in your browser with JavaScript. At dim/Rapier 3D for using the WASM version of Rapier 3D in your browser with JavaScript. We announced Rapier for the first time at the end of August 2020. Since then, we implemented some essential features like raycasting, collision filters, access to contact information, rotation logging, and the support of shapes like cylinders and cones. We made sure our cross-platform determinism feature works properly on the new Apple M1 ARM processor, and we set up continuous benchmarking visible on the Rapier website to make sure incremental changes don't destroy performances. During December 2020, we started working on a large refactoring of the geometry-related code existing partly inside of Collide and partly inside of Rapier itself. This refactoring is still work in progress. As part of the CDL repository, the name isn't definitive. Don't hesitate to share your opinion on that issue. This work will be ready for the beginning of February 2021, and will allow us to proceed with our 2021 goals. Rapier roadmap for 2021 hash. We have very exciting goals for Rapier in 2021. Basically, at the end of 2021, we want Rapier to have all the features one would expect from a physics engine for games. This implies achieving feature parity with popular C++ physics engines like Box2D, Bullet Physics, and Physics. There is one exception though. We don't plan to support running physics simulations on the GPU yet, though this may become a focus at some point in the next years. Here is a list of some of the most important features we are missing today. This includes when they should become available, ETA, feature description at 64 bits floats at F64 version of Rapier for greater accuracy. February sweep. Test similar to raycast, except that we are casting a whole shape instead of just array. This is often used to design character controllers. February intersection. Queries to retrieve all colliders intersecting a given shape. February convex polyhedron 2. Use an arbitrary convex polyhedron as a collider shape. February custom shapes to allow the user to define their own shape types. February contact modification to allow the user to modify/delete a contact before it is handed over to the constraint solver. Note that the contact modification feature is what will allow you to simulate one-way platforms, conveyor belts, as well as colliders with non-uniform restitution and friction coefficients. We also intend to implement some higher-level features like a character controller and a vehicle controller. Both should be available starting October. Most games will need controllers obeying their specific custom rules, so it is impossible to design a universal solution. Our goal is to provide something useful to start with, to serve as a basis to more specific character and vehicle controllers. Finally, the last months of 2021 should be mostly dedicated to improving documentations and fixing bugs. Our Bevy plugins and JS bindings will be updated progressively through the year in order to always use the latest version of Rapier. We also developed Solva, a 2D and 3D fluid simulation engine written in Rust. Solva implements two-ways coupling with Rapier. This means that fluids from Solva can be affected by contact forces originating from Rapier, and rigid bodies from Rapier can be affected by forces originating from fluids. Our 2021 objectives for Solva are cross-platform determinism. Just like Rapier, we want to make Solva optionally cross-platform deterministic, under the same assumption of IEEE 754-2008 compliance. Performance improvements. We need to apply to solve what we learn from Rapier with explicit SIMD optimizations. Stability improvements. To improve the quality of the fluid simulation itself and of the two-ways coupling with Rapier. We intend to work on the first two objectives from February to May 2021. The stability improvements will be a progressive work during the rest of the year. As of today, we don't plan to create JavaScript bindings for Solva. However, this can happen if there is enough demand from the community. Conclusion hash. The Rust game development community is growing every day as an ecosystem is maturing steadily with major crates like the Amethyst and Bevy Game Engine, Rust Poo Project, and many other incredible projects. By working on Rapier and some of its dependencies, full-time we aim to provide a high-quality, free, open-source, community-friendly, cross-platform game physics simulation library. The year 2021 will allow us to make Rapier reach a level of feature completeness comparable to its main C++ alternatives. If you would like to support us with the development of Rapier, please consider sponsoring us on GitHub Sponsor. Thank again to all our existing, past, and future sponsors for making all of this possible. Have a great year 2021. Rigid bodies. The real-time simulation of rigid bodies subjected to forces and contacts is the main feature of a physics engine for video games, robotics, or animation. Rigid bodies are typically used to simulate the dynamics of non-deformable solids as well as to integrate the trajectory of solids which velocities are controlled by the user, for example moving platforms. On the other hand, rigid bodies are not enough to simulate, for example, cars, ragdolls, or robotic systems, as those use cases require adding restrictions on the relative motion between their parts using joints. Note that rigid bodies are only responsible for the dynamics and kinematics of the solid. Colliders can be attached to a rigid body to specify its shape and enable collision detection. A rigid body without collider attached to it will not be affected by contacts, because there is no shape to compute contact against. Creation and insertion hash. A rigid body is created by a world.createRigidBody method. The initial state of the rigid body to create is described by an instance of the rigid body DSC class. Each rigid body created by the physics world is given an integer identifier rigidbody.handle. This identifier is guaranteed to be different from any identifier of rigid body still existing or that existed in the physics world. The following example shows several setters that can be called to customize the rigid body being built. The input values are just random, so using this example as is will not lead to a useful result. Example 2D, example 3D, / the world that will contain our rigid bodies. Let world equals new Rapier world. X 0.0, Y minus 9.81, / builder for a fixed rigid body. Let underscore equals rigid body DSC dot fixed, / builder for a dynamic rigid body. Let underscore equals rigid body DSC dot dynamic, / builder for a kinematic rigid body controlled at the velocity level. Let underscore equals rigid body DSC dot kinematic velocity based, / builder for a kinematic rigid body controlled at the position level. Let underscore equals rigid body DSC dot kinematic position based, / builder for a body with a status specified by an enum. Let rigid body DSC equals new rigid body DSC Rapier rigid body type dot dynamic, / Typically, the inertia and center of mass are automatically set to the inertia and center of mass resulting from the shapes of the colliders attached to the rigid body, but they can also be set manually. Rigid body type hash. There are three types of rigid bodies, identified by the rigid body type enumeration. Rigid body type dynamic indicates that the body is affected by external forces and contacts. Rigid body type fixed indicates the body cannot move. It acts as if it has an infinite mass and will not be affected by any force. It will continue to collide with dynamic bodies, but not with fixed nor with kinematic bodies. This is typically used for the ground or for temporarily freezing a body. Rigid body type kinematic position based indicates that the body position must not be altered by the physics engine. The user is free to set its next position and the body velocity will be deduced at each update accordingly to ensure a realistic behavior of dynamic bodies in contact with it. This is typically used for moving platforms, elevators, etc. Rigid body type kinematic velocity based indicates that the body velocity must not be altered by the physics engine. The user is free to set its velocity and the next body position will be deduced at each update accordingly to ensure a realistic behavior of dynamic bodies in contact with it. This is typically used for moving platforms, elevators, etc. Both position-based and velocity-based kinematic bodies are mostly the same. Choosing between both is mostly a matter of preference between position-based control and velocity-based control. The whole point of kinematic bodies is to let the user have total control over their trajectory. This means that kinematic bodies will simply ignore any contact force and go through walls in the ground. In other words, if you tell the kinematic to go somewhere, it will go there, no questions asked. Taking obstacles into account needs to be done manually either by using scene queries to detect nearby obstacles or by using the built-in character controller. Position hash. The position of a rigid body represents its location, translation, in 2D or 3D world space, as well as its orientation, rotation. The position of a rigid body can be set when creating it. It can also be set after its creation as illustrated below. Warning. Directly changing the position of a rigid body is equivalent to teleporting it. This is not a physically realistic action. Teleporting a dynamic or kinematic bodies may result in odd behaviors, especially if it teleports into a space occupied by other objects. For dynamic bodies, forces, impulses, or velocity modification should be preferred. For kinematic bodies, see the discussion after the examples below. Example 2D, example 3D, / set the position when the rigid body is created, / let rigid body DSC equals Rapier rigid body DSC dot dynamic, / the rigid body translation, / default, 0 vector, dot set translation 0.0, 5.0, / the rigid body rotation, / default, no rotation, set rotation 5.0, let rigid body equals world dot create rigid body DSC, copy / set the position after the rigid body creation, / the true argument make sure the rigid body is await dot rigid body dot set translation, x 0.0, y 5.0, true, rigid body dot set rotation 0.2, true, copy / set the position when the rigid body is created, / let rigid body DSC equals Rapier rigid body DSC dot dynamic, / the rigid body translation, / default, 0 vector, dot set translation 0.0, 5.0, 1.0, / the rigid body rotation as a quaternion, / default, no rotation, set rotation, w 1.0, x 0.0, y 0.0, / the true argument make sure the rigid body is await dot rigid body dot set translation, x 0.0, y 5.0, z 1.0, true. In order to move a dynamic rigid body, it is strongly discouraged to set its position directly as it may result in weird behaviors. It's as if the rigid body teleports itself, which is a non-physical behavior. For dynamic bodies, it is recommended to either set its velocity or to apply forces or impulses. For velocity-based kinematic bodies, it is recommended to set its velocity instead of setting its position directly. For position-based kinematic bodies, it is recommended to use the special methods. Rigid body dot set next kinematic position, rigid body dot set next kinematic rotation, rigid body dot set next kinematic translation. These methods will let the physics pipeline compute the fictitious velocity of the position-based kinematic body for more realistic interactions with other rigid bodies. These methods won't immediately modify the position of the kinematic body itself. The position of the kinematic body will be automatically set to these values during the next physics pipeline update. The velocity of a dynamic rigid body controls how fast it is moving in time. The velocity is applied at the center of mass of the rigid body and is composed of two independent parts. The linear velocity. In order to move a dynamic rigid body, it is strongly discouraged to set its position directly as it may result in weird behaviors. It's as if the rigid body teleports itself, which is a non-physical behavior. For dynamic bodies, it is recommended to either set its velocity or to apply forces or impulses. For velocity-based kinematic bodies, it is recommended to set its velocity instead of setting its position directly. For position-based kinematic bodies, it is recommended to use the special methods. Rigid body dot set next kinematic position, rigid body dot set next kinematic rotation, rigid body dot set next kinematic translation. These methods will let the physics pipeline compute the fictitious velocity of the position-based kinematic body for more realistic interactions with other rigid bodies. These methods won't immediately modify the position of the kinematic body itself. The position of the kinematic body will be automatically set to these values during the next physics pipeline update. The velocity of a dynamic rigid body controls how fast it is moving in time. The velocity is applied at the center of mass of the rigid body and is composed of two independent parts. The linear velocity is specified as a vector representing the direction and magnitude magnitude of the movement. In 3D, the angular velocity is given as a vector representing the rotation axis multiplied by the rotation angular speed in rad/s, axis angle representation. In 2D, the angular velocity is given as a real representing the angular speed in rad/s. The velocity is only relevant to dynamic rigid bodies. It has not effect on fixed rigid bodies, and the velocity of kinematic rigid bodies are automatically computed at each time step based on their next kinematic positions. The velocity of a rigid body is automatically updated by the physics pipeline after taking forces, contacts, and joints into account. It can be set when the rigid body is created or after its creation. Example 2D. Example 3D. Set the velocities when the rigid body is created. Let rigid body dsc equals Rapier rigid body dsc dot dynamic. The linear velocity of this body. Default 0 velocity. Set limbo 1.0 3.0 the angular velocity of this body. Default 0 velocity. Set angle 3.0. Let rigid body equals world dot create rigid body dsc. Copy set the velocities after the rigid body creation. The true argument make sure the rigid body is awake dot rigid body dot set limbo x 1.0 y 3.0 true rigid body dot set angle 3.0 true copy set the velocities when the rigid body is created. Let rigid body dsc equals Rapier rigid body dsc dot dynamic. The linear velocity of this body. Default 0 velocity. Set limbo 1.0 3.0 4.0 the angular velocity of this body. Default 0 velocity. Set angle x 3.0 y 0.0 z 0.0. Let rigid body equals world dot create rigid body dsc. Copy set the velocities after the rigid body create. The true argument make sure the rigid body is awake dot rigid body dot. Alternatively, the velocity of a dynamic rigid body can be altered indirectly by applying a force or an impulse. Gravity is such a common force that it is implemented as a special case, even if it could easily be implemented by the user using force application. The gravity is given to the constructor of the physics world. It can be modified by modifying the field world dot gravity. Note, however, that a change of gravity won't automatically wake up the sleeping body, so keep in mind that you may want to wake them up manually before a gravity change. Because fixed and kinematic bodies are immune to forces, they are not affected by gravity. Info: a rigid body with no mass will not be affected by gravity either. So if your rigid body doesn't fall when you expected it to, make sure it has a mass set explicitly, or has at least one collider with non-zero density attached to it. It is possible to change the way gravity affects a specific rigid body by setting the rigid body's gravity scale to a value other than 1.0. The magnitude of the gravity applied to this body will be multiplied by the scaling factor. Therefore, a gravity scale set to 0.0 will disable gravity for the rigid body, whereas a gravity scale set to 2.0 will make it twice as strong. A negative value will flip the direction of the gravity for this rigid body. This gravity scale factor can be set when the rigid body is created or after its creation. Set the gravity scale when the rigid body is created. Let rigid body dsc equals Rapier rigid body dsc dot dynamic. Set gravity scale 2.0. Let rigid body equals world dot create rigid body dsc. Copy. Set the gravity scale after the rigid body creation. Rigid body dot set gravity scale 2.0. True. Copy. Forces and impulses hash. In addition to gravity, it is possible to add custom forces, or torques, or apply impulses, or torque impulses, to dynamic rigid bodies in order to make them move in specific ways. Forces affect the rigid body's acceleration, whereas impulses affect the rigid body's velocity. They are both based on the familiar equations. Forces: the acceleration change is equal to the force divided by the mass. Delta A equals m 1f. Impulses: the velocity change is equal to the impulse divided by the mass. Delta V equals m 1i. Forces can be added, and impulses can be applied to a rigid body after it has been created. Added forces are persistent across simulation steps and can be cleared manually. Example 3D. The true argument make sure the rigid body is awake dot rigid body dot reset forces true. Reset the forces to 0 dot rigid body dot reset torques true. Reset the torques to 0 dot rigid body dot add force x 0.0 y 1000.0 true rigid body dot add torque 100.0 true rigid body dot add force at point x 0.0 y 1000.0 x 1.0 y 2.0 true rigid body dot apply impulse x 0.0 y 1000.0 true rigid body dot apply torque impulse 100.0 true rigid body dot apply impulse at point. Keep in mind that a dynamic rigid body with a zero mass won't be affected by a linear force slash impulse, and a rigid body with a zero angular inertia won't be affected by torque impulses. So if your force doesn't appear to do anything, make sure that the rigid body is dynamic. It is strong enough to make the rigid body move. Try a very large value and see if it does something. The rigid body has a non-zero mass or angular inertia either because they were set explicitly or because they were computed automatically from colliders with non-zero densities. Mass properties hash. The mass properties of a rigid body is composed of three parts. The mass which determines the resistance of the rigid body WRT. Linear movements. A high mass implies that larger forces are needed to make the rigid body translate. The angular inertia determines the resistance of the rigid body WRT. The angular movements. A high angular inertia implies that larger torques are needed to make the rigid body rotate. The center of mass determines relative to what points torques are applied to the rigid body. 0 is a special value for masses and angular inertia. A mass equal to 0 is interpreted as an infinite mass. An angular inertia equal to 0 is interpreted as an infinite angular inertia. Therefore, a rigid body with a mass equal to 0 will not be affected by any force, and a rigid body with an angular inertia equal to 0 will not be affected by any torque. Computing the mass and angular inertia can often be difficult because they depend on the geometric shape of the object being simulated. This is why they are automatically computed by Rapier when a collider is attached to the rigid body. The collider adds its own mass and angular inertia contribution, computed based on the collider shape and density, to the rigid body it is attached to. Let rigid body dsc equals rigid body dsc dot dynamic. Let rigid body equals world dot create rigid body dsc / the default density is 1.0. We are setting 2.0 for this example. Let collider dsc equals collider dsc dot ball 1.0. Set density 2.0 / when the collider is attached. The rigid body's mass and angular / inertia is automatically updated to take the collider into account. World dot create collider rigid body copy. Alternatively, it is possible to set the mass properties of a rigid body when it is created. Keep in mind that this won't prevent the collider's contributions to be added to these values. So make sure to set the attached collider's densities to 0 if you want your explicit values to be the final mass properties values. Example 2D. Example 3D. Set the mass properties when the rigid body is created. Let rigid body dsc equals Rapier rigid body dsc dot dynamic. Set additional mass 0.5. Set additional principal angular inertia 0.3. Sets both the mass and angular inertia at once. Set additional mass property 0.5. Let rigid body dsc equals Rapier rigid body. Set additional mass property 0.5. Locking translation / rotations hash. It is sometimes useful to prevent a rigid body from rotating or translating. One typical use case for locking rotations is to prevent a player model as a dynamic rigid body from tilting. These kind of degree of freedom restrictions could be achieved by joints, but locking translation / rotations of a single rigid body WRT, the Cartesian coordinate axes, can be done in a much more efficient and numerically stable way. That's why rigid bodies have dedicated methods for this. Example 3D. Lock translation / rotations when the rigid body is created. Damping hash. Damping lets you slow down a rigid body automatically. This can be used to achieve a wide variety of effects like fake air friction. Each rigid body is given a linear damping coefficient, affecting its linear velocity, and an angular damping coefficient, affecting its angular velocity. Larger values of the damping coefficients lead to a stronger slowdowns. Their default values are 0.0, no damping at all. This damping coefficients can be set when the rigid body is created or after its creation. Set the damping coefficients when the rigid body is created. Let rigid body dsc equals Rapier rigid body dsc dot dynamic. Set linear damping 0.5. Dominance is a non-realistic, but sometimes useful, feature. It can be used to make one rigid body immune to forces originating from contacts with some other bodies. For example, this can be used to model a player represented as a dynamic rigid body that cannot be pushed back by any, or some, other dynamic rigid bodies part of the environment. Each rigid body is part of a dominance group in -127. 127. The default group is 0. If the colliders from two rigid bodies are in contact, the one with the highest dominance will act as if it has an infinite mass, making it immune to the contact forces the other body would apply on it. If both bodies are part of the same dominance group, then their contacts will work in the usual way. Both are affected by opposite forces with the same magnitude. For example, if a dynamic body A is in the dominance group 10 and a dynamic body B in the dominance group -20, then a contact between a collider attached to A and a collider attached to B will result in A remaining immobile and B being pushed by A, independently from their mass. Info. A non-dynamic rigid body is always considered as being part of a dominance group greater than any dynamic rigid body. This means that dynamic/fixed and dynamic/kinematic contacts will continue to work normally, independently from the dominance group they were given by the user. The dominance group can be set when the rigid body is created or after its creation. Set the damping coefficients when the rigid body is created. Let rigid body DSC equals Rapier rigid body DSC dot dynamic. Set dominance group 10. Let rigid body equals world dot create rigid body DSC. Copy. Set the damping coefficients after the rigid body creation. Rigid body dot set dominance group 10. Copy. Continuous collision detection hash. Continuous collision detection (CCD) is used to make sure that fast-moving objects don't miss any contacts. A problem usually called tunneling. This is done by using motion clamping, i.e., each fast-moving rigid body with CCD enabled will be stopped at the time where their first contact happened, taking their continuous motion into account. This will result in some time loss for that rigid body. This loss of time can be reduced by increasing the maximum number of CCD substeps executed. The default being 1 in the integration parameters. By changing the integration parameters .max CCD substeps field, Rapier implements nonlinear CCD, meaning that it takes into account both the angular and translational motion of the rigid body. CCD takes action only if the CCD enabled rigid body is moving fast relative to another rigid body. Therefore, it is useless to enable CCD on fixed rigid bodies and rigid bodies that are expected to move slowly. By default, CCD is disabled for all the rigid bodies because it requires additional computations. It can be enabled when creating a rigid body or after its creation. Enable CCD when the rigid body is created. Let rigid body DSC equals Rapier rigid body DSC dot dynamic. Set CCD enable true. Let rigid body equals world dot create rigid body DSC. Copy. Enable CCD after the rigid body creation. Rigid body dot enable CCD true. Copy. Sleeping hash. When a dynamic rigid body doesn't move or moves very slowly during a few seconds, it will be marked as sleeping by the physics pipeline. Rigid bodies marked as sleeping are no longer simulated by the physics engine until they are woken up. That way the physics engine doesn't waste any computational resources simulating objects that don't actually move. They are woken up automatically whenever another non-sleeping rigid body starts interacting with them, either with a joint or with one of its attached colliders generating contacts. However, a sleeping rigid body won't respond to any user action. This is why it is possible to wake up the rigid body manually with rigid body.wakeup. Some rigid body methods take an additional wake up boolean argument that, if true, ensures that the rigid body wakes up before the action takes place. For example, rigid body.add force. True, will wake up the rigid body before adding the force. World.remove joint. True, will wake up the two rigid bodies attached by the removed joints. World.remove collider. True, will wake up the rigid body the removed collider is attached to. Unless you want to achieve special effects, it is recommended to always set the wake up argument to true. One example of case where setting the argument of wake up to false makes sense is to simulate a custom constant gravity with rigid body.add force. False. This will result in the force being applied to the rigid body, but will allow the rigid body to fall asleep if it reaches a dynamic equilibrium.
So I realize now what's the difference between the way that I was doing and the way that the guy does it. Is he puts the rest length there, and that's the stuff that is gonna make it so that they stop moving. And then obviously from the documentation there, I think that and I remembered reading something like that they recommend to change the forces instead of changing the X and Y position, because changing the position is like teleporting the thing. But it is kind of annoying because I have to think about like what is gonna happen when I create the force. And the issue is that the simplest way I think is just to reset the forces and then add the force again. But I'm not sure if that's very good or not. And here I'm gonna change this thing here as well, because it's just kind of annoying as well because I don't wanna spend time thinking, to be honest. So yeah, I think that I have to pass the 3 different bodies anyway. I'm thinking like the way that I'm thinking now is that I'm gonna use this function here as well in the other file, and then just call the function again. But I have to think like how I'm gonna do this, because I'm gonna have to update the X and Y position, I think. Or I can pass X and Y as well, but then I have to make this based on the X and Y that I pass. It's kind of annoying. Or I can pass the distance here. And then for each one, I'm gonna have to calculate. So I'm gonna do the distance between the mouse, X and Y, and the nodes, the neighbor position, the neighbors. So but I think I have to pass the bodies anyway because I need to add the forces later. So let me think about it. And then here, obviously, I'm gonna put the node, the rest length as well. I think the first thing I'm gonna do is try to fix this function here so that it works. So I'm gonna put rest length here. Then I think about the other stuff. I'm gonna watch the video again. The question is, should I put X and Y again or make it based on the... Yeah, but if I make it based on the bodies, then the issue is that I have to change the body anyway, the position. So I need to pass X and Y. The question is... And I need to pass the bodies, I think. So I'm gonna have to do both. Which is kind of annoying, but... Also, I wanna see how this function... Yeah, here it is setting translation as well. Maybe I should just pass the bodies and then I set translation before. And then I pass the 2 bodies. I think that's probably the easiest, since he's doing this way as well here. And then I have to see how can I add the correct velocity as well. Applying both stacks or... And where's the acceleration coming from? Oh, maybe yes, because this was probably initialized in the end there. Oh no, it's up here. It's just an arbitrary number. Hmm. And it is interesting though that he only sets the translation when the distance is small. So that's the thing. Maybe, but I guess that here is different because this is for the click event. When you click, the ball goes to the place you clicked. Which obviously I'm not gonna do it. So, but I still have this example here just so I can see if it is useful for the one that I want to do. Yeah, I think the best way is probably to leave it like this and then set the translation. So, let's see. I also don't understand why I did it though. Like this. Yeah. I have the distance here. The force. Also gonna I think I'm gonna delete this part and just make. I'm gonna probably try to copy from the tutorial from the guy as much as possible because it looks like he does it the correct way. So the thing is gonna be the force times the max. Maybe the rest length. It probably doesn't matter to go here. It's the same thing. Not sure which one is best though. And then this is the thing is. I also think I should put on the two bodies the force. It makes more sense. Yeah, let's see if it works now. Something wrong. I thought you could pass default arguments in JavaScript. Maybe I'm not remembering correctly. So obviously there's something wrong here. Oh, I think that the reason why it was the other way is because there's something with the object. I don't remember. I think that I, I didn't. I don't know for sure, but I remember there was a problem and I thought that it might be because of the reference to different objects. But let me think. It's weird that they are exploding. So let's see here. It's not gonna have any difference. So it's probably because of the is getting undefined there, but I'm not really sure why though. These ones are undefined. Yeah, I don't understand why. It's probably because of the reference. This here body. So what's the difference between accessing this directly and I guess it's because of the problem is the destructuring of the thing. That's why. So yeah, just do it like this. Oops. Yeah, there we go. Now this is the thing, is that they're being pushed away from each other. Let me think about it. So the issue is that the force should be a scalar. So, because the distance is like this, the square root. So like it's always going to be positive, obviously. So this is a positive number times a constant minus the minimum amount, let's say. And this times dx and dy. So I think that this might be the problem. But I don't see why though, because like it should be a vector representing the maybe it's because one of the forces that should be the negative of the other one, but I think it shouldn't be necessary to get the magnitude. It's clearly wrong. Let me think.
I'll begin with just this really basic sketch, just one variable, just y itself. So y being 200. So we'll say that y position 200, the spring will assume is attached to the top, and then the rest length would therefore be 200, or 200 minus y. So the displacement, or x, would be wherever the current y is, minus 200. And I should make that a variable. So in this case, the displacement is 0. The spring shouldn't move, which is what I see. But what happens if the displacement is not 0? Like if I make it 250. So clearly it should spring back up. So I need to calculate that force that I've got over there. And I can make up a spring constant. Let's just use the value 1 for lack of anything else right now. So what do I do with that force? How does that force change the y position? Well, this goes back to the sort of core foundational principles of my nature code series. An object has a position, the velocity changes the position, the acceleration changes the velocity. I covered that extensively. I'll link to those videos here. Other thing that's really critical about that series is Newton's second law. Force equals mass times acceleration. And if I were to simplify that law, I'd just say, well, forget about the mass, it's equal to 1 for everything in our world. Force equals acceleration, or acceleration equals force. So if I were to say the velocity changes by the force, which is the same as acceleration, and the position, which is y in this case, changes by the velocity, that's all I need. Change y by velocity, change velocity by force. The only thing is I need a velocity variable, and I need it to start at 0. Oh boy, okay, interesting. I'm getting something. It's springy for sure, but I think the issue here is my value of k is much too high. So let's use a lower value. And we can see there it is, springing back and forth. Look at that spring. Oh, it's so springy. So let me add a little damping in here and just say velocity times equals 0.99, meaning it's going to lose 1% of its velocity every time, every frame. And that's kind of like how you might imagine maybe there's some air resistance or some other kind of force that slows the spring down over time. And eventually it comes back to at rest. All right, so you can pause this video now and maybe try some interesting things. Have more than one spring because you kind of move it up and down with the mouse because you have to go left and right. But really, there's not a lot that I can do with this without adding in the idea of a vector. So let me redraw this diagram with it at an angle so that we can bring in the concept of vectors here. I mean, the concept of vectors could have existed with my previous diagram. It's just I think I'm going to be able to illustrate it better if it's at an angle. Now, if vectors are unfamiliar to you, again, I could refer you back to that whole video series about vectors, but the idea of a vector in one sentence is an entity with magnitude and direction. And so I could draw it in this diagram here as an arrow. This could be the spring force. It has two elements to it. It has its direction, which way is it pointing? Back towards the bob, or towards the anchor, I suppose, and it has a magnitude. How strong is it? What is its length? This formula still gives me the magnitude. The force of the spring, the magnitude, the length of this vector is negative k, the spring constant, times x, the displacement. The issue is I need to figure out the direction. And the way that I can figure out the direction is if I know the anchor point, if I know this as position A, and I know where the bob is, currently down here, if I call this position B, I can create a vector that points from A all the way to B by taking B minus A. If we think
I guess I understand what's wrong here. Like I'm doing it slightly different than he is, I think. The problem is that the rest length here. It shouldn't be here. I think it should be here, maybe. Yeah, because it has to be rest length minus the force. Because if I do it here, then the smaller the distance is, it just increases the force. So this is always going to be negative, and then, yeah, unless, yeah, if, maybe not. Because if it is between 0 and 1, then let's say k 22 times 1, the distance is still a positive force. Obviously, for them to reach 0, the rest length is equal to k times distance. With k divided by... It's gonna be less than 1. Let's make 22 true, so it's easier. Let's see if it works. But I think I should put the rest length somewhere else. And the thing that is confusing the fuck out of me is the direction of the forces. Because clearly this one is repelling the other one, but this one is attracting. And that's this stuff that I don't understand as well. Like, why is that the case? It's obviously because of the vector, but that's the problem. Because I'm calculating based on the difference, and then the force is a scalar, so I think that depending on the direction that the initial position is, it fucks up the direction of the forces, because both of them are the same, like the same sign. That's the problem. Because in order for them to always be pulling towards each other, I need to vectorize, I think. I need to like calculate the... I can't make based on the distance, I think, the force. Yes, should be the constant times the vector for both of them. And then I have to think about how to always make them attracted to each other. That's what's confusing me, I think. I think the example that it does there is slightly different. Let's see if I put... I also think that this is not necessary. Should I just do it here? Also don't... Yeah, I don't know why I'm multiplying by the x and y. The issue is that I got this stuff from VGS, so... Or there might be stuff that I was missing there from... And this is not very accurate, so it's probably better to just delete all of this. It should be just the distance times k. Let's see if I make it like this. Yeah, but this is the thing, because then... Yeah, I can't make based on the distance, so... If I'm gonna pass a vector here... So it should be just dx instead of distance. But this is the problem, because this is not guaranteed to be positive, so it's gonna depend on where the nodes are at. And I think that elevating them to the power of 2 and then getting the square is not very good, probably. Just to make it positive. So maybe I should put the condition, but that also feels it's not the best. Let me just try to copy whatever the guy did here. I think I'm gonna stop here streaming, and I'm gonna watch this, and then because then I can use the 2 monitors, and I'm just gonna copy the stuff that he does here. Then maybe I'll come back and try to implement the zoom later. Like, it's not hard to... The physics is obviously not hard, but it's just annoying to think about. Because you have to think about all the possible positions that the nodes are going to be in relationship to each other and how the vectors are going to change. And then how to update the force in the correct way there. I think that the only thing that I'm going to have to do here is just set the translation and then call the function again. It's just about getting this function right. I was thinking about getting this function right after I solved this thing here, because it makes it easier to test if you can drag the node around, but I think that I can't really do this one first. I have to do this one, and then once I get this one correct, then I can just set the translation and call the function again. And I'm gonna call obviously inside of the neighbors, because I have to update the forces in relationship to all the neighbors. Yeah, I think you don't need to update everything, because the only thing that changes is the ones that are directly connected. And then by changing the forces on them, it's gonna change the forces on the other ones, if there are more than one edge, because the results is going to be the vector of the forces, I think. So if you have 2 different edges, like the vector, the resulting force of the node is going to be the vectorial sum of the forces, I think, applied to the body. So if you change just the forces directly connected to the one that you're moving, is going to change everything else. Hopefully. And then after that, I think it's gonna work, and I'm just gonna forget about using this joint, because it just makes things more complicated, I think. If it works, obviously. I'm gonna stop here, and then maybe after I solve this, I come back, sure. But I might just do... Because I'm gonna have to study as well the zoom again, to see exactly... It's gonna take a time, I think. It's gonna take a lot of time either way to understand how the zoom changes everything else, and how to update the physics engine after changing the zoom. But the first thing that I think I'm gonna try after I solve this is just to pass the viewport instead of passing the viewport instead of passing this app wrapper, which is a div, or pass the viewport as the app wrapper, so that I can see if the zoom is gonna work or not. Because now I think it's not working, because I'm appending everything here in relationship to the app and not the viewport. So even though the events for the viewport are working, they don't change the visualization, because it's just changing the container of the viewport, and the stuff on the visualization is not a child of the viewport. So the first thing that I'm going to do is try to put the elements as children of the viewport and see if it's going to change the visualization. Then after that, I'm going to see if I can just copy the functions from Pixi-viewport and apply them directly there, to see on the events, to see if it's going to change the visualization the same way. Yeah, so that's probably what I'm going to do. But I'm going to stop here now, I think. Let's try to do this stuff off stream. Maybe I'll come back today, maybe I'll come back another time. And I'm gonna continue to work on this. So yeah, see you then.